Topic 2.5, solving linear inequalities. Now when it comes to inequalities, the answers look a little different than the equations. Equations, x equals a number, 5, and that's it. But with the inequalities, we have to look at answers being on a graph. And there's 3 ways that we write or express solutions of inequalities. Okay, so let's look at the properties of linear inequalities. First, there is set notation. Then there's the graphic notation or representation. And then there's interval notation. Okay. So let's look at an example of set notation. Set notation would have the variable will always be to the left of the inequality. X is greater than or equal to 3. So again, for set notation, the main thing is that the x, when solved, ends up on the left side of the equation. For graphic notation, we put a number line here, put 3 here, and because this is an equal sign, we make this solid at 3. Then, since this is greater than 3, the line will only go to the right. So, the graphic for this would be solid at 3 and to the right only. For interval notation, we would have on the left side a bracket for the 3, which means equals to 3. And since the right side is infinity, or going to a positive infinity, we write positive infinity and always put a parenthesis for all infinities. So set notation, graphic notation, and the interval notation. Okay, let's take a look at an example of another one. Let's say x is less than 3. Okay, so this is the set notation. Again, you see the x is on the left side. Furthermore, we'll put 3 here, but instead of a closed circle, we're going to put an open circle. The reason why we have the open circle is because there is no equal sign here like we had here. Here, equal sign closed, no equal sign open. And this is less than goes to the left. And that is your graphic notation. The interval notation for this would be to the left, since it's going, it'll be parentheses negative infinity since it's going to the left, and to the right it only goes as far as 3, and it's open. Therefore, we'll use a parenthesis at 3 rather than a bracket at 3. Okay. Next, type of set notation is, let's say, x is within 3 and 5. X is within 3 and 5. Whenever you see a set notation here where x is between 2 numbers, the notation, the graphic notation for that would be a line segment. And this end, because it matches the equal sign here, will be closed, and this end, there's no equal sign, this end will be open. So 3 and 5 are here. So the graphic notation again is a line segment with closed and open ends. The interval notation for that would be bracket for 3 and to 5 parentheses. So all the numbers between 3 and 5 including 3. All the numbers between 3 and 5 including 3. All the numbers between 3 and 5 including the number 3. Okay. Now, last thing we want to deal with is combinations. What if we had a combination of, let's say, x is less than or equal to 3, or x is greater than 5. Okay, these combinations are treated this way. You graph them individually. This piece would be 3 closed, 3 here, closed, and since it's less than, it'll go to the left. This side right here will be a 5, we'll have 5. There's no equal sign, so open. X is greater than, this will go to the left. Okay. So you just write both pieces individually, and that's it. For interval notation, we represent this piece right here as parenthesis negative infinity to 3 with a bracket. Then the OR piece we treat as a union. We put a union there. So this, any answers can come out of this side, or any answers, other answers can come out of the side over here. Parentheses 5, comma, positive infinity. Okay, so these are examples of how to deal with set notation, graphic notation, interval notation. And the idea is to be able to be given any one of these and produce the other two. It's like speaking in one language and being able to interpret it to other languages. So make sure you can go from one to any other language here when it comes to the notations of inequalities. Okay, now let's begin to solve some problems, and we're going to solve them and speak in all 3 languages. We'll first get the set notation language, and then we'll answer in the graphic and interval notation language. Okay. So let's solve. Okay, on the first one, we're going to solve just like a regular equation, and we're going to first subtract 5 from both sides. So we want to keep x on the left side when it comes to inequalities. So subtracting 5 from both sides, we end up with 3x is greater than or equal to 6. Then I divide both sides by 3, and we get the set notation answer, x is greater than or equal to 2. So this is one form, this is one answer. Now the graphic for this will be a 2 here, and then a closed dot, and since that's greater than, it'll go to the right. So this is the graphic notation for this. Now the interval notation will be bracket 2, comma, positive infinity to the right. So these are all 3 ways of answering this. Okay. All right, number 2. Typically, we solve to the side of our largest x. Here we got a negative 2x and a positive 1x. Sorry, a negative 1x. That's the larger x. But when it comes to interval notation, we always solve our x's to the left. So let's begin. Plus x plus x. I end up with negative 1x plus 8 is greater than negative 16. From there, we're going to subtract 8 from both sides. I end up with negative x is greater than negative 24. Now from here, I'm going to divide by negative 1. When I divide or multiply by negative numbers, we get a sign change. So this now becomes positive x, a less than sign, and a 24. And this is the set notation answer. Every once in a while, you'll see set notation with a little additional piece here, x such that x is less than 24. But this is not as needed. You can put it there. I don't mind. But to me, it's a little simpler just keeping it this way. Okay. Now, the graphic for this. This will be a 24 with an open circle. And x is less than means it goes to the left. Then the interval notation will be open parentheses, negative infinity, then the 24, and then a parentheses for the 24 since it's not closed or there's no equal sign. So these are the 3 ways of writing the solution. You will need to know that. Here, our x is on the right side, we need it on the left side. Here's a little trick to actually get the x on the left side instantly. We're going to actually pull this equation off the board, turn it around, and then place it back on. that will place the x on the left side. So this will become a negative 2x plus 14. Okay, this goes over here. The 6 goes over there. And with the flip, this goes from greater than to a less than sign. And now the x is actually on the left side. And again, I just simply pulled the equation off the board, flipped it over, and placed it back down to get the x on the left. All right, so let's begin the process. Subtracting 14 from both sides, I end up with negative 2x is less than, let's see here, negative 8. And then we're going to divide everything by a negative 2. Dividing by negatives or multiplying by negatives changes the signs, so we get x is greater than 4. And that's our interval notation. Not interval notation, sorry, the set notation. The graphic would be an open circle at 4, because there's no equal sign, and this is greater than, so it'll go to the right. And the interval notation for this will be parentheses 4 to positive infinity. And those are your 4 ways of writing the same solution. Okay. Number 4 will have 2x plus 3 all over 4 is greater than or equal to 3x minus 2 all over 5. And number 5 will have negative 3 is less than or equal to 2x plus 5 is less than or equal to 11. Okay, smooth that over a little bit. 5, let's see, negative 3 less than or equal to 2x plus 5 less than or equal to 11. All right, smoothing that over a bit. Now working with this one. First thing we want to do is we want to get rid of the denominators. We get rid of the denominators by multiplying through by the least common denominator, a number that, the smallest number that 4 and 5 will go into, and that number will be 20. So we're going to multiply everything by 20. And the denominators for dividing, the numerators for multiplying. So the LCD, least common denominator, divided by 4 times the numerator will be 5 times x plus 3. Again, 20 divided by 4 times the numerator would end up being 5 times x plus 3. No, times 2x plus 3. 20 divided by 5 times the numerator will be 4 times x minus 2. Times the 3x minus 2. 3x minus 2. From here I'm going to distribute. So I'll get 10x plus 15 for the left. Distributing again, 4 times 3x gives me 12x. 4 times negative 2 gives me negative 8. Okay, I have x's on the left and x's on the right. Typically we solve to the larger x's, which is right there, the 12x is larger than 10. But with inequalities, we try to solve everything to the left. Or we do solve everything to the left. So minus 12x here, minus 12x there. And we get negative 2x plus 15 is greater than or equal to negative 8. And now we're going to subtract 15 from both sides. And that'll give us negative 2x is greater than or equal to negative 23. I want to divide by negative 2 to isolate the x. We'll get a sign change because we're dividing by a negative. And so we get x is less than or equal to positive 23 over 2. And this is the set notation answer. The interval notation, the graphic would be a 23 over 2 with a closed circle. And since this is less than, it'll go to the left. Now, the interval notation will be a parentheses, negative infinity for the left side, comma, 23 over 2, bracket, close bracket, for the right side. And those are your 3 ways of writing the solution. Next, the x is within. That means that we have to isolate the x from and keep it within this bracket right here, or within these 2 terms. So we're going to get rid of the 5 first and then the 2. I'm going to subtract 5, and the rule is whatever you do to one side, you do to all sides. So if I'm subtracting 5 here, I must subtract 5 here and here. This gives me negative 8 less than or equal to 2x, or less than or equal to 6. Next, I want to get rid of the 2 from the x, so I'm going to divide by 2. But whatever you do to one side, you do to all sides. And so what we have is a negative 4 less than or equal to x less than or equal to 3. And that is the answer in set notation. Now, what would the graphic look like for that? This will be a line segment where it's closed on the left and on the right because of the equal signs at negative 4, bad looking 4, and positive 3, and that's it. Now, the interval notation would be a bracket at negative 4 to 3 and a bracket at 3. This means we get to use, the solution is all the numbers in between negative 4 and 3, including the numbers negative 4 and 3. Number 6, negative 1 less than x minus 2 all over 3 less than or equal to 1. Number 7 will be the absolute value of 2/3 x minus 5 less than 3. And problem number 8, the absolute value of 2/3 x minus 5 greater than 3. Greater than or equal to. Let me add that equal sign there. Okay, with this problem right here, we want to solve for x, so we're going to multiply to get rid of the 3 and add 2 to get rid of the negative 2. So first, let's multiply everything by a 3. We'll end up with negative 3. 3's cancel here, you'll get x minus 2. And 3 times 1 is 3. And from here, I'm going to add 2 to both sides. And now we have a negative 1 is less than x is less than or equal to 5. And this is our set notation. The graphic for this will be a line segment with an open circle at negative 1 and a closed circle at 5. The interval notation for this will be a parentheses at negative 1, a 5, and a bracket. So these are the 3 answers. Now number 7 and 8. How to remove the absolute value signs. There's 2 ways to remove the absolute value signs. If the absolute value signs are followed with a less than, you do remove the signs. So you get 2/3 x minus 5 less than 3. And you put another less than or equal to on this sign and the opposite of this number, which is negative 3. Okay, that's your rule. When removing absolute value signs with a less than sign, you put another less than or equal to sign here with the opposite of that number here. And then we solve. So I'm going to add 5 here, then add 5 here, and add 5 there. This will give me 2 less than or equal to 2/3 x less than or equal to 8. Now from here, to get rid of the 2 over 3, I'm going to multiply this by 3 over 2. So 8 divided by 2 is 4. 4 times 3 is 12. 2 over 3 cancels out with 3 over 2, so we're left with x. And 2 divided by 2 is 1, and 1 times the numerator 3 is 3. So x is between 3 and 12. That's a line segment that's closed at 3 and closed at 12. And the interval notation for that will be bracket 3 to 12. Okay. And those are your 3 answers, or 3 ways of writing the same answer. Now, dealing with absolute value sign and greater than signs. For this, we need to break this up into 2 pieces. Okay. Our first piece will be without the absolute value signs. 2/3 x minus 5 is greater than equal to 3. Then we write it again over here, 2/3 x minus 5, but we change the absolute value sign. In fact, I want to reverse this. I want to put this one on the right side. So I'm going to start this again, and I need a little more room. Okay. All right. So on the right side, I'm going to simply remove the absolute value signs. Everything stays the same. So 2/3 x minus 5 greater than or equal to 3. Okay. Now for the left side, I'm going to remove the absolute values and I'll make 2 changes. The change on the sign and the change on the sign for that one. So 2/3 x minus 5 is less than -3. And now we're going to solve. Here I'm going to add 5 to both sides. And I'll get 2/3 x is less than or equal to 2. Then we'll multiply everything by a 3 over 2, which will make that a 1x. 3 over 2 times 2 is 6 over 2, which is 3. Okay, so that piece right there is finished. Now for the other side, I'm going to add 5 to both sides, and I'll get 2/3 x is greater than or equal to 8. Then we'll multiply both sides by 3 over 2. That'll cancel out the 2 over 3, giving us 1x, and make this greater than or equal to 4 times 3 is 12. And these are our 2 answers. X is less than 3 or x is greater than 12. Now, the graphic for this would be 3 with a closed circle, and since it's less than, it will go to the left. This will be 12 with a closed circle, and greater than means we go to the right. And that's your graph. Next, your interval notation would be -infinity to 3 with a bracket, union, this piece right here, which will be bracket 12 to positive infinity. Okay, and one more, number 9. Number 9 is the absolute value of 2/5 x plus 4 is greater than 2. Now, what I'm going to do with this one is I'm going to YouTube this. I'm going to YouTube number 9, YouTube number 7, and also YouTube number 8. So all 3 of these will be required for your YouTube. Alright, so once again, same procedure as there. And let's kind of get some room here. Alright, so this absolute value is greater than 2, so we'll split this into 2 pieces. So we'll have 2/5 x plus 4 is greater than 2. No changes. But over here on the left side, we'll have 2/5 x plus 4 is less than a -2. Okay, here, subtracting 4 from both sides, I end up with 2/5 x is less than -6. Then I'm going to multiply everything by 5 over 2, which will give me 1x is less than, let's see, negative 3 times 5 is negative 15. On this side, subtracting 4 from both sides, this will give me 2/5 x is greater than negative 2. You're going to multiply everything here by 5 over 2, and we end up with a 1x is greater than 2 divided by 2 is negative 1 times 5 is negative 5. Alright, so these are your two answers in set notation. Now, a graphic for this is x is less than negative 15 is a negative 15 with an open circle headed to the left. This is a negative 5 with an open circle, but greater than says the graph is headed to the right. So this is your graph. The interval notation would be left side negative infinity, right side negative 15, parentheses, union negative 5 to positive infinity to the right. And these will be your three answers right there.